Example 2, magnitude of a vector. If v is a vector with given points x, y, and the terminal point x2, y2, then the magnitude is given by taking the what's called the terminal point and subtracting the initial x, so terminal x minus initial x and square it, and then the terminal y minus the initial y and squaring that. It's the Pythagorean theorem is all this is. Here's a symbol for magnitude. It's like absolute value around the bold vector symbol. And so here, again, it's just like Pythagorean theorem. To find the magnitude, you take the square root of a squared plus b squared. That's how we find magnitude. So here, we'll first do it algebraically. You have an initial point and a terminal point. And again, what you need to remember whenever you see the words terminal and initial is you're going to take the terminal and subtract the initial. To give you a physical representation of this, it's like here's a vector. The point that it's pointing to, that's the terminal point. This right here is the initial. And if you go back a slide, you'll see that you take your ending point and you subtract the initial point. So that's what we're going to do here. So first I'll write it as a vector, and I'm going to use the calculator form here. I take the terminal x, which is 3, and I'm going to subtract the initial x, which is -2. And then for my y's, I'll take my terminal y, which is 7, and subtract my initial y, which is a -5. Now, each of these have a negative. If you distribute these through, these become positive because they're two negatives. Two negatives become a positive, and the same is true here. And so this simplifies to become 5, 12. Now, in the previous example, all we had to find was component form or rectangular. That's what that is. This is component form and rectangular form. So I'll write it over here. This is component or rectangular form. It's the x and y. That's what we have here. But we're not asking that for that. We're looking for magnitude, which is the h, if you will, the h and theta. Well, the theta would be the direction. Magnitude is simply the h. So now we can do Pythagorean theorem. And so here's the magnitude for vector AB would equal the square root of 5 squared plus 12 squared. I'm doing the Pythagorean theorem here. And so 5 squared is 25. 12 squared is 144. And if you add those together, we get the square root of 169, which equals 13. So 13 is our magnitude for the vector AB. Now, I'm going to show you how to do this whole thing in the calculator as well. What you can do is if you come over to your calculator, and we'll add a calculator, I'm going to go to vector symbols, just those brackets, just like as if these were originally vectors. Even though they're originally points, we're going to treat it as if they were vectors. I'll do 3, 7, and then what I'm going to do is I'll come out here and I'll add, or excuse me, I'm going to subtract, not add. I'm doing terminal minus initial. So I'll do another bracket here. My initial is -2, -5. And when I add those, I get that rectangular component form, which is 5, 12. And then you go menu, 7 for matrix and vectors, C, which again is a vector, and then hit 4 for polar. Menu 7C4. When you do that, you get the H 13, and the angle would be 67.4 degrees. Now I have one for you to try.